Hey guys, so on the last video note, you were supposed to solve for y on your own. Hopefully you did that. Um, Now, if you didn't do it, that means you must not have gotten a credit stamp, right? If I've already gone around and checked all of the video notes. So let's take this opportunity to learn how to solve for y. So to solve for y, meaning that I'm going to have to get y all by itself. So I will subtract this piece over here. Okay. So we're going to take this and move it over. So subtract the entire piece. Okay. The entire piece. You don't need to distribute, because if you do, it's going to be really messy. So if I subtract that, I'm going to end up with y plus 1 in quantity square equals 1 minus quantity x minus 3 square. So now that we have moved this to the other side, we have this piece left. Now our goal is to solve for y because this is how we can enter it in your calculator. So now we are going to take square root. Okay, square root, square root. Anytime that you're taking a square root, you're going to end up with two answers, always. So y plus 1 equals plus or minus 1 minus x minus 3 quantity. And again, you don't need to distribute this out, okay, because the reason we're solving for y is so that we can enter it in your calculator, and your calculator can do all of that. So now we're just going to subtract 1 to both sides, minus 1, and put it behind, okay? So y equals plus or minus 1 minus x plus 3 square minus 1. So this is what you should have gotten for your y equal formula. So what this means is you have two half circles, okay? Let me spell this out. Let me get a different color pen. The positive half, okay? Meaning that you have, and that means is the top half of the circle. Okay, so oops. Top half of the circle. The negative square root, so negative square root is the bottom half of the circle. So if I asked you, hey, you know what, just give me the top half of the circle, then you would only give me the positive piece of it. If I said, hey, give me the negative half of the circle, that means you're giving me the bottom half of your circle. Okay? So the y equals form is sort of making it two different equations. One is to graph the first half, one is to graph the second half. All right, let's move on to part C. Remember, the direction is exactly the same. Let me find it for us. Where did it go? Okay, so the direction for this is still graph the circle by hand and use and by using the graphing calculator. So you're going to need to do both. Okay. Then find the intercepts of each circle. Did we do that yet? Intercept each circle. Huh. That's a piece that we didn't do. All right. Then for this one, make sure we do that because I forgot to do that piece. All right. Here we go. Notice how this one is not in the nice HK form. So what you need to do is to put it in HK form. Okay. So let's zoom in so you can see the problem. So the first thing is we are going to put all the x's together and all the y's together and all the constant to the other side. So I have 2x squared. I'm going to write 2x squared. This is a 2y squared. I'm not going to put it together with x's, so I got those two. I should put it together. So plus ax plus a blank space. Okay. Then we are now going to put y together, but I only have one y, so right now that y is going to be standing all by itself. Then I have this positive 7 in which I need to subtract it to the other side, so it becomes a negative 7. So the rule of thumb is put all the x's together, put all the y's together, and move the constant to the other side. Okay. Before we can do the completing the square, so remember this example up here, we needed to complete the square to get into HK form, and that's what we need to do here. To complete the square, though, you may never have a leading coefficient. See this right here in front of the y square or x square. May not have leading coefficient in front of x squared or y squared. Ever. Ever, ever, ever. So I would have to factor it out. Now to factor it out, you are going to just group the x's together and the y together, just like that, okay? So because I have 2x squared plus 8x, I will take out the leading coefficients only. Okay, you do not look for a common term, just the leading coefficient. So take out the 2. So now I have x squared plus, nope, not 8, but 4x. Sorry, plus 4x plus a blank space. Over here, you can technically pull out a 2, but because there are no other terms besides the 2y squared, you can right now leave it the way it is. Okay? Because for this one, I don't need to factor. There's only one term. Now from here, let's see what we can add in here. Okay? So we're going to, remember this piece, you need to take half of the b term, which is this. Okay, same thing. We're going to write it in red. Here we go. Here's your b. Okay, so half of b term, which is really 4. Okay, so 4 divided by 2 is 2, and then you're going to square it. So 2 squared equals 4. I'm going to add it here. Okay, so I've added a 4 on the left, which that means I need to add a 4 on the right. Okay, but check this out. This 4 is being multiplied to a 2 in the front. So this 4 also needs to be multiplied to a 2 in the front. So whatever you do on one side, it needs to be identical to the other. So now that we have this piece, we have 2, we need to factor out this trinomial. And just like earlier, this comes out to be x plus 2 times x plus 2, okay, because when you factor out, they're identical. And that's really, your job right here is to find the perfect trinomial. This is what's called perfect trinomial. That means when you factor it out, it has 2 identical factors. Bring down your 2y squared, because I don't need to factor that, equals -7 plus 8 is a positive 1. Okay. Now notice how we still have that leading coefficient. That's kind of annoying. You would need to divide that, but let me do a couple of things. I'm going to put this together as an x plus 2 squared. Bring down my 2y squared equals 1. Now you have to get rid of these 2 numbers here, okay, by dividing each and every term by the leading coefficient. In this case, it's actually a 2. So cancel that. So I'm going to end up with x plus 2 squared. 2y squared divided by 2 is simply a y squared equals now a 1/2. So this is my vertex form, not a vertex form, my HK form. Okay, I know the radius is square root of 1/2, so r squared equals 1/2. That means r, which means I need to take a square root of 1/2, equal to, that's the same thing, same square root of 1 and square root of 2. So that means square root of 1 is 1. Square root of 2, I would need to simplify that. So let's try to multiply this by square root of 2 by square root of 2. So that's going to give me radius. Ready? R equals square root of 2 over 2. Okay. Then let's look for the center. The center is h comma k. Okay. Well, h is here. Remember, you always need, this is an x minus a minus 2, right? X minus -2. So my h is really negative. Okay. So h is -2. Well, this is just simply y squared. It doesn't have anything with it, so it's just 0. Okay. Now earlier, when I was reading the direction, it says find the intercepts as well. That means x-intercept and y-intercept. And intercepts are easy to find. Okay, let's move it up here. Intercepts. Let's find x first, okay? X-intercept, meaning y has to be 0. So something blank, and then this is 0. Okay. X-intercept, y has to be 0. So when y is 0, all I have left, let's use this pencil, it's x plus 2 squared equals 1/2. I will take the square root of both sides. Here we go. Whoop, whoop. Okay. And if I'm going too fast, you do need to pause and then rewind it. Okay. So anytime I'm taking a square root, I should have 2 answers. So x plus 2 equals plus or minus. Square root of 1 is 1, just like what we've done already on the bottom. Okay, square root of 2 is just simply square root of 2, which now I need to rationalize. So now I have x plus 2 equals square root of 2 plus or minus, I'm sorry, all over 2. And my goal is still to solve for x, so I'm going to move 2 to the other side, so that would turn itself to a negative. So x equals plus or minus square root of 2 over 2, take away 2. So that is my x-intercept, okay, right there. So I have two x-intercepts, plus or minus. Here we go. Square root of 2 over 2, and then I have a subtract of 2. Oh, that's such an ugly answer, isn't it? You know, I don't like the way I write that, so let me just erase it. I'm just gonna give myself a larger space there. So let me white out the 0, because that doesn't look anything like what I want it to look. All right, I'm just gonna give myself a little bit bigger space. Okay. Okay, let it dry. All right, so as I'm letting that one white out piece dried up, I'm going to look for the y-intercept. Y-intercept when x is 0. So here we go. I'm going to, how about put it over here? Okay, let's do it. Make space. Y-int is when x is 0. So hopefully that is enough space for what I'm about to do. Well, when x is 0, here we go. 0 plus 2 is going to be 2. 2 squares 4. So now I have 4 plus y squared equals 1/2. Okay. Can you guys see that? All right, let me zoom out. Let's do that one more time. All right, there. All right. So y-intercept was when x is 0. So this is 0. 0 plus 2 is 2. 2 squared, that gives me 4. Bring the y squared over, set it equals to what we had before, which is 1/2. Subtract 4 from both sides. So y squared equals 1/2 take away 4. I'm going to give you guys a second to figure that out. One-half take away 4. I hope you wrote down -3.5. Okay. Now we are going to square root both sides. Okay. But we have an issue. Can I ever take a square root of a negative number? I hope you said no. So my y-intercept is none. Okay, so I don't have any y-intercept. What this means is that my circle will never, ever, 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 ever cross over the x-axis. All right, now that I think this is all dried up, let's put my answer back. X-intercept, here we go, plus, minus 2 rad 2 over 2, okay, then minus a 2, comma 0. That looks better. There you go. This -2 needs to line up. Okay, it can't just be on the top, or it just can't be on the bottom. It needs to line up with this rad 2 over 2. All right, so now that we have the intercepts, no y-intercept, but we have an x-intercept, we have the radius, we have the center. Let's see if I can sketch this out. Okay, your radius is really small. Notice how the radius is square root of 1/2. So I'm just gonna plot the center first, which is -2, comma 0. So I'm going to make my tick marks really large. Here we go, -1, -2. See that right there? And because the radius, if r squared is 1/2, taking a square root of 1/2 is really small. Okay, so -2, comma 0 is my center. See that right there? Now, let's try to figure out what square root of 1/2 is. And by hand, by just, from our brains, and then we can check with the calculator to see if we are close. Okay, so let's talk about square root numbers. Square root of 0 is 0, right? Square root of 1 is 1. Square root of 4 is 2. So notice how, well, square root of 1/2 is somewhere here. Okay, so I can for sure know that square root of 1/2 is in between 0 and 1. Can't be 1, can't be 0. So I know if I put a dot, let's just say square root of 1/2 is maybe, what do you think? anything in between 0 and 1, we would be okay. So we can do like maybe like a little bit less than half. What do you think? Okay, so r, which is the radius, r squared over here, let's look, r squared equals 1/2. That means r squared root of half. Okay, so that means I'm going to need to plot a dot less than a half. Okay, like that. And because my tick marks is right here, so that means here's half, I'm just going to go a little bit less than a half. And then here's a little bit of less than a half. And here is a little bit less than a half. So there you go. Remember, notice how my tick marks are really large spaced out because I know my radius was going to be really small. So there's my circle. Okay. All right, so let's, oh, that is, all right, there you go. Round it out. Don't make it look like a diamond or a square. Make it round. Make your 4 dots nicely. Okay. Now let's check out what the square root of a half is, okay? Because we were guessing by hand with using our brains that it would be a little bit less than a half. So I'm going to put in square root of 0.5 and hit enter. Okay, so it's actually more than a half. It's 0.71-ish. So, but that's all right. Okay, as long as you put a dot in between 0 and 1, because when you don't have a calculator, you don't know the exact value. So just put a dot in between 0 and 1. You will be okay. You can put it as close to 1 as you want, or as close as or the other way as you wish, as long as not on 0 or 1 in terms of distance. Okay. All right. That is the end of that. So this one problem right here was talking about how to complete the square with the leading coefficient. So make sure you listen to it again, and really do mean it, okay, if you didn't get it the first time around. Now, we are now moving on to parabolas. And parabolas, as we have been graphing it forever since you learned Algebra 1 or even earlier, okay? But today I'm going to help you review how to complete the square, just like what we did with circles, if we want to put it in vertex form. So let's define parabolas first, okay? And as you recalled, how do we get a parabola from our cone? To get a parabola, notice how if we take a knife or a plane, we cut it slanted, okay, in a slanted way on the cone, then we would get a parabola. If you cut it straight up and down with a double cone, then we would get a hyperbola. But we are only going to focus on the parabola and circles for this one. So let's move that here. Let's straighten out my papers. Here we go. Definition of a parabola. It is a set of all points. Okay. Parabola is a set of all points equal distance. Okay, a set of all points equal distance from a line and a fixed point, or let's say a line from a line called the directrix, and a point called the focus. Okay. Okay. The standard form of a parabola is going to be f of x equals, or even y equals, doesn't really matter which form you are using, ax squared plus bx plus c, where a can never ever be 0. Okay. Why is it that a can't be 0? What's the reason behind that? What is the reason that a can never ever be 0? If a is 0, then this x squared term is gone. Then that means I'm going to end up with just a line with b as my slope and c as my y-intercept, and that is not a parabola. So that's why this is restricted to where a can never ever be 0. Okay. Let's move on to the vertex form. The vertex form, which is your HK form, which we have seen already in Algebra 2. Again, this is really, it shouldn't be new information for us. This is a review. So vertex forms y equals a times the quantity of x minus h squared plus k, where, again, a can never ever be 0 because that will give us a line. And the vertex is h comma k. Okay? And the vertex is h comma k. So this piece, let's look at the directions, because I tend to forget what we want to do, so I want to make sure I cover all bases. Okay, the direction sets write each in vertex form. That means I want it in the HK form. Graph each parabola by hand. Determine the intercepts and local min or local max if applicable. So I want to make sure I highlight this, okay, so I don't forget. So let's see, should I space this out so I don't invade the other spots? Okay, let's see. Let me use a pencil. I'm going to go like this. I tend to really do invade the other problem's personal space, so this way I won't. Okay, let's write down, rewrite in each vertex form. So let's write vertex form, and then we'll put an answer here. We're going to graph it. Okay, so vertex, put our answer here once I have it. I'm going to graph it by hand. And then how about intercepts? We'll put all the intercepts here. Okay. And we're going to find our local min here and local max. This way, I know these are all the things I'm supposed to answer. Okay. Box them up. All right, let's go. Y equals x squared minus 12. Oh, you know what? That's a typo. Can you put an x right there for me? Add an x in there. Okay. Plus 46. All right, here we go. Add an x. To put this in vertex form, we are going to complete this square. So the first thing I would like for you to do is make this equal to 0. Make it equal to 0, just like that. Okay. And just like your circle, the constant, okay, instead of moving it to the other side, you can move it to the right a little bit. So here's what we're going to do. We are going to 0 equals x squared minus 12x plus, okay, I want you to do a space, just like the circles, and move this 46 slightly further out a little bit, okay. Now to get this, to fill in this blank space, remember we take half of 12, so go ahead and write half of 12. What is half of that? So write your answer out. Half of negative 12 or 12, it doesn't matter because when you square it, it will always become positive. So you don't need to worry about writing the negative. So half of negative 12 is negative 6. Or you can even write half of 12 is positive 6. Then you're going to square it, and I want you to write the answer right here. When you square that, what do you get? Hopefully you wrote down 36, right? I'm not going to write it for you, okay, just because some students are not really listening to the video. When I stamp this, I want to see who wrote 36 and who didn't. So I'm just going to continue. X squared minus 12x, okay, plus that blank space, which you're supposed to write down, plus 46. Now we are going to factor out just this piece, okay? When you factor that, you are going to end up with an x minus 6 and x minus 6 twice, and then bring down the 46. And that's okay. We're going to keep the 46 as is. Then I'm just going to write it as 0 equals x minus 6 squared and bring down my 46. So notice how from here, we now have our HK form. You can put the y back if you want. X minus 6 squared plus 46. Okay. So the vertex is simply just 6 comma 46. So let's go back up and write our vertex. 6 comma 46. And vertex is a point. Okay, vertex is a point. So make sure you write it using parentheses as our notation. Then we need to find our local min and local max at intercepts, okay? So to find the intercepts, let's find y-intercept first, or x-intercept first. It doesn't matter. Which one do you guys want to find first? Let's do x, right? X-intercept, that means y is 0. So 0 equals x minus 6 squared plus 46, okay? Let's solve for x. So minus 46 from both sides. So negative 46 equals x minus 6 squared. We are going to take the square root. So here we go. Square root and square root. Okay, so when we take the square root, notice how I can't take the square root of a negative 46. So x-intercept, we're going to say none. So we're going to write up here, no x int. Okay. Now to find y-int, we are going to set x equals to 0. So here we go. Y equals 0 minus 6 squared plus 46. So 0 minus 6 is negative 6. Negative 6 squared is going to give me a positive 36 plus 46. So this is going to give me, go ahead and write down your answer. Go ahead and write your answer right here. Did you say 82? Okay, so go ahead and fill that in. And again, I'm not filling everything in just because I want to see if who's listening and who's not. All right, so y-intercept is x is 0, and we know that spot is supposed to be 82. Oh my goodness, that is quite large of a y-intercept. Okay, so we have the vertex, we have the y-intercept. Let's try to graph it out, okay? It opens, okay, so now let's look at how this opens. We have a vertex form of, let's box this up, because it did say right in vertex form. We have a vertex form already. See this right here? It's a positive one, so we know it opens up, okay? If it opens up, is that going to give us a local min or local max? If it opens up, it will give us a local min. So local max, I can say none right away. Local max is the same as the vertex. I'm sorry, local max is none. Local min is the same as the vertex. It depends on how it opens. But these two, the min and the max and the vertex, they're identical. You just have to know which one to write that vertex piece in. Okay, so now I have the tiny piece of space left on the bottom. Looks like I have a y-intercept of 82, so that's a positive number. Okay, so I'm gonna have to scale my y-axis. I don't have any negative y, so I don't need a lot of space at the bottom. So I'm gonna space it out at, let's see, 40 and 80, right? X-axis looks like it's by, how about 2? 2, 4, 6. 2, 4, negative 6. Okay, like that. So x-axis is by 2's, y-axis is by 40. So look at our vertex. We have a vertex at 6 comma positive 46. So 40, so 46 is somewhere here. It opens up. We have a y-intercept is 0 comma 82. So 0 comma 82. So right now I have one side of my parabola. Parabola is, oops, can you see that? Here we go, 0, 82. Parabola is symmetrical, so I could have one, I could go the same distance on the right, so 0, so that's 6 units to the left. That means I can go 6 units to the right, so this is 12. And then I can go up to 82. Okay, so this is 12 comma 82. So there you go. Okay. All right. So this is 12 comma 82. Make sure that's known. All right, so that's how we put it in the vertex form. Make sure we find the x-intercept if applicable, y-intercept if applicable. The local min and local max will come from the vertex. Okay, you just have to know which one it belongs to, local min or local max. Okay, and as you can tell, because it opens up, the vertex is now the local min. All right, so with that said, we are going to stop right here. I will continue the next video with part B and part C. Have a wonderful day.